Hello everyone, welcome to this comprehensive guide on outcome-based education, or we call it OBE, which is an educational paradigm used worldwide to ensure that graduates develop the knowledge and skills needed for professional success. So whether you are an educator or a student or a maybe program evaluator or a curriculum designer, this video will help you understand OBE, its components, the overall accreditation process, the assessment methods, and international perspectives, including NCEAC, NCEAC, which is the Accreditation Council in Pakistan. So let's get started. Let's first see what is outcome-based education. So outcome-based education focuses on what students are expected to learn and demonstrate by the time they graduate. So it shifts the focus from what teachers teach to what students learn. The core principles include these four: the clarity of focus, so learning outcomes are clearly defined, the alignment, curriculum, teaching methods, and assessments clearly align with the outcomes. Flexibility, so instructors can choose the best strategies to help the students achieve those outcomes. And finally, continuous quality improvement, which we call CQI, in which decisions are data driven, that ensures basically ongoing enhancement in learning. So globally, OBE is implemented through accreditation councils. In the US, ABEET is the principal regulator for the engineering and computing programs. Many countries follow standards under the Washington Accord or EURACE. In Pakistan, the National Computing Education Accreditation Council, NCEAC or NCEAC, accredits the computing related degrees, including computer science, software engineering, information and technology, and AI. So while each body has its unique guidelines, the underlying structure, including the PEOs, PLOs, CLOs, and CQI, that basically remains consistent across the world. So we will learn in a moment all these underlying concepts. This session will help you understand how BSSE program is designed, evaluated, and continuously improved using OBE and CQI frameworks as required by NCEAC. So it helps the students understand what is expected and how they are assessed and how they can map their learning to the industry needs. So the purpose of this session is to help you understand specifically how your BSSE, BS Software Engineering program is designed, evaluated, and continuously improved using OBE and CQI frameworks as required by NCEAC. So it will help students learn what is expected and how they are assessed and how they can map their learning to the industry needs. So let's see the underlying structure and the concepts involved, like PEOs, PLOs, CLOs, and CQI. Let's first see what program education objectives, that is PEOs, is. PEO describe what graduates are expected to achieve 3 to 5 years after education. So these outcomes are sort of broad, aspirational, and aligned with the educational or institutional missions. For example, graduates will excel in professional computing careers. This is one of the PEO. Another example could be graduates will demonstrate ethical and social responsibilities. So PEOs are developed through consultation with stakeholders such as faculty members, industry, alumni, employers, and different accreditation bodies. Next, program level objectives, that is PLO. PLO define what students must know and be able to do by the time they graduate. So these outcomes relate to the skills, competencies, or can say attitudes and professional standards. So globally, PLOs often align with the frameworks such as ABET outcomes. For example, NCEAC uses PLOs such as problem analysis, computing knowledge, design and solution development, ethics, communication, and teamwork. So these outcomes help ensure the graduates are industry ready. And then CLOs, course level outcomes. So for each course, you define specific measurable learning outcomes that contribute to one or more PLOs. For example, for a certain course, a course learning outcome can be that is, a student will, for example, a CLO for a certain course could be students will be able to implement sorting algorithms, or students will be able to analyze maybe time complexity. So these outcomes relate specifically to the course, so they are at the course level. The National Computing Education Accreditation Council, NCEAC, has defined 12 PLOs that are aligned with internationally recognized outcome frameworks such as ABET and Washington Accord. These PLOs ensure that graduates acquire the knowledge, skills, and professional attributes required for efficient engineering and computing practice. So these PLOs are, as you can see, engineering knowledge. First one is engineering knowledge. So you apply the knowledge of mathematics, science, engineering fundamentals, and computing principles to solve complex engineering problems. Next is problem analysis. So you identify and try to formulate or analyze or research complex engineering problems using the first principles of mathematics, science and engineering. Third one is designing solutions for complex engineering problems, and design system components or processes that meet specific needs with appropriate consideration for maybe public health, safety, cultural or societal factors. Fourth one is investigation. So you conduct investigations of complex problems using research-based knowledge and research methods, including design of experiments, analysis of data, and synthesis of information. Fifth one is modern tool usage. You select and create and apply appropriate techniques, resources, and modern IT or engineering tools, including maybe modeling tools with an understanding of their limitation. Sixth one is engineer and society. So you apply reasoning informed by the contextual knowledge to assess societal safety, health, legal, and maybe cultural issues relevant to the professional engineering practice. Next is environment and sustainability. You understand the impact of professional engineering solutions in societal and environmental context, and you try to demonstrate the knowledge of sustainable development. Next, ethics. You apply ethical principles and commit to professional ethics, responsibilities, and norms of the engineering practice. Next outcome is individual and teamwork. So you function effectively as an individual, as a member or a leader in diverse and maybe multidisciplinary teams. Next is communication. So you communicate effectively on complex engineering activities with the engineering community and with society at large, including the ability to comprehend and write effective reports, design documentation, and deliver presentations. Then 11th one is project management. Demonstrate the knowledge and understanding. So project management is to demonstrate the knowledge and understanding of management practices and principles and apply those to one's own work as a member or again as a leader in the team to manage projects in multidisciplinary environment. And finally, lifelong learning means to recognize the need for or have the ability to engage in independent and lifelong learning in the context of technological change. So every course in a degree program is mapped to one or more of these PLOs. This ensures the systematic coverage and progressive development of competencies through the curriculum. So this structured mapping enables outcome-based education and compliance with the international accreditation standards. Next is PEO, Program Educational Objectives. So these describe the expected achievement of the graduates 3 to 5 years after graduation. So this reflects the professional achievements or accomplishments, career progression, and societal contributions of an alumni, and are aligned with the program mission, institutional goals maybe, industry expectations, and societal needs, of course. So for BS Software Engineering degree, the following PEOs are defined. For example, first PEO is that graduates will excel in professional engineering roles by applying technical knowledge or problem solving skills or industry relevant practices. Second one means graduate will contribute ethically and responsibly to society and organizations by adhering to the professional standards, legal frameworks, and social responsibilities. Third one is the graduates will demonstrate continuous learning and professional development by adapting to the emerging technologies and pursuing advanced education or professional certifications. Fourth one is that graduates will show leadership and teamwork abilities by effectively contributing and leading to multidisciplinary and technology-driven environment. So these PLO establish a clear linkage between your academic program and post-graduation outcomes. So this basically ensures that a program remains responsive to the technological advancements, the industry needs, and the societal changes. So this supports continuous improvement and stakeholder engagement. So CLO to PLO mapping is the heart of OBE, that is outcome-based education. Each course contributes to one or more program learning outcomes, that is PLO. A mapping matrix is created to identify which CLO supports which PLO. As you can see this matrix on the screen. So this ensures alignment across the curriculum and provides evidence through accreditation that the program systematically develops each required competency. So the HEC recently in 2025 notified revised curricula for many disciplines, including business and management studies, social sciences, and others. And the purpose is to enhance academic standards and align them with industry needs and incorporate evolving market trends, so by bringing the degree programs in line with the international standards. So the revised curricula explicitly adopt an OBE framework. So each programs include program education objectives and program level objectives, that is PEO and PLOs. So this means for Pakistani institutions, OBE is just not just nice to have, it's now embedded in your HEC curriculum standards for many disciplines, not only obviously engineering and computing. And this matters globally because OBE framework is not just a foreign or Western accreditation idea, but it is an adopted locally in non-Western higher education systems to align them with global standards. So this helps your global audience appreciate how outcome-based accreditation works across different national contexts with local adaptations. Now let's go through PEOs, PLOs, and CLOs as defined in HEC approved programs with examples. Number 1, PEOs. So PEOs, program education objectives. As per HEC curricula, PEOs remain broad and long-term objectives for graduates. For example, a sample PEO for an engineering curricula include things like graduate will have knowledge and skills, work and grow professionally, practice ethically, socially, and environmentally responsibly. So institutions are allowed to customize their PEOs according to their mission, vision, and stakeholder input. Next, PLOs define what a student must know or must be able to do upon graduation. Example of PLO list adopted by some Pakistani universities working under OBE and HEC alignment are as shown. PLO number 1 is engineering knowledge, PLO 2 is problem analysis, PLO 3 is design and development, PLO 4 is investigation, PLO 5 is tool usage, PLO 6 is engineer and society, PLO 7 is environmental and sustainability, PLO 8 is ethics, PLO 9 is teamwork and individual work, PLO 10 is communication, and PLO 11 is project management, and finally PLO 12 is lifelong learning. Next is course level outcomes, CLOs. So CLO for each course you define specific measurable learning outcomes that contribute to one or more PLOs and ultimately towards achieving your program education objectives. For example, a course on data structures may have a CLO like a student will implement and analyze common data structures, or a student will evaluate algorithm complexity. So each CLO must map to PLO, one or more PLOs. So you can trace how every course contributes to program level graduate attributes. Under OBE framework, assessments are designed to directly measure the achievement of course learning outcomes and their alignment with program learning outcomes. So each assessment activity is intentionally mapped to one or more CLOs to ensure meaningful evaluation of student learning. A variety of assessment tools are used to comprehensively evaluate student performance, including quizzes, assignments, lab work, projects, or final examination. These assessment instruments collectively ensure coverage of cognitive and practical and professional skills. The students are evaluated not only on numerical marks but also on their level of attainment of defined outcomes. So for each CLO, specific items are identified. For example, CLO 1 may be assessed through assignment 1 and quiz 2. Student performance on these assessment components is analyzed to determine your CLO attainment. To ensure quality and continuous improvement, CLO achievement target must be defined, and typically CLO is considered attained when, for example, more than 60% of the students meet or exceed a specified performance criteria. If the target is not achieved, corrective actions such as curriculum revision, maybe assessment redesign, or additional student support are implemented. So this structured assessment approach provides a quantitative evidence of outcome attainment and supports continuous improvement in line with NCEAC and international accreditation standards. Now let's see what is CQI. CQI stands for Continuous Quality Improvement, and it is the process by which institutions use assessment data from CLOs, PLOs, and your stakeholder feedback to define and improve curriculum, teaching methods, resources, support, and align the outcomes with the real world needs. So it transforms the OBE from a static plan to a living system that evolves as outcomes, your environment, technology, and stakeholder expectations change. CQI process involves a cycle of PDCA, that is plan, do, check, and act. Plan means you define intended outcomes, that are PEOs, PLOs, your CLOs, and you design curriculum, assessment, or teaching strategies and decide what data to collect. In do, you deliver courses, collect assessment results, feedback, and other related data. And in check phase, you analyze the results. That is how many students met a CLO or a PLO, what weaknesses have emerged, gather indirect feedback from students or alumni and employers. And in last phase, you take corrective or improvement actions, like you try to revise the curriculum or change your teaching method or methodology, add a support, update maybe your resources, redesign assessment, and things like that. Direct assessment and indirect data assessments are two common data sources that are used in CQI. Direct assessment data may include exam and quiz result, your project's result, your lab assessment result, assignments mapped to CLOs, and by extension eventually to PLOs. And indirect data include student course feedback surveys, maybe the exit surveys, alumni surveys, employer surveys, the internship assessment, maybe industry advisory board inputs, peer reviews, and accreditation reports. There may be other supporting evidence, for example enrollment and dropout rates, maybe, or employment outcomes of graduates, further study rates, internship performance, maybe capstone project evaluation, and employer feedback. So let's see why is this important for students. So students benefit from understanding OBE and CQI because they know the exact expectations of each course. They can track their PLO achievement, they can explain their skills in interviews, and they understand the international quality standards behind their degree, and they can contribute meaningfully through feedback for CQI. So here is a sample evaluation rubric. You can record this data in some Excel for your reference as an instructor. That includes student ID, your course name or course code, CLO number or CLO description, the assessment type, the maximum marks achieved by students or marks awarded, and number of students meeting that target, and any other observation or comments. So similarly, a PLO attainment sheet can be also recorded where you aggregate CLO level data to compute PLO attainment. So for each CLO you define a rubric, for example a project or a lab, and you can define that scale, for example excellent, more than 85%, for example if a student meets all the criteria, demonstrates mastery and good documentation, correct design and thorough analysis. And then a satisfactory level, when a student meets most criteria but there are some minor flaws in documentation or analysis maybe. And the marginal level, more than 50%, that means students meet some criteria but has some noticeable weaknesses and they're partially correct. And finally unsatisfactory, you can mark that less than 50%. So students fail to meet significant criteria, for example major issues or some missing work. So these performance levels can be color coded or maybe in green, yellow and red color for clarity. Let's see an example. Suppose in a BS computer science program, after first 2 years, the data shows that PLO modern tool usage attainment is very low. Only 50% or 55% of the students meet the required level. And secondly, the employer feedback, your survey, also indicates that students lack practical tool based software development experience. So in CQI you can take an action like introduce additional lab courses or workshops, and you try to revise your existing courses to include more practical assignments and adaptation of new software tools, provide industrial internships, and then re-evaluate this after next cycle. Now let's see how to analyze and use the data. So for each course or semester, you compute how many students attained each CLO, and from these PLOs, if certain PLOs are lagging, for example modern tool usage or teamwork is lagging, then you flag that for improvement. You collate also the indirect feedback from student feedback, your alumni or employer surveys. For example, if many alumni say they felt underprepared in communication skills, then you try to increase or emphasize or add new courses or assignments targeting communication. So in the act phase of CQI, you revise the course content, you add workshops, update lab infrastructure, or revise your teaching or assessment methods. Now let's go through some templates to see how CLOs are mapped to PLOs. Let's begin with the CLO-PLO mapping matrix, which is one of the most critical documents in outcome-based education. The purpose of this sheet is to show how each course learning outcome contributes to one or more PLO. Accreditation bodies such as NCEAC and other require clear evidence of this alignment. So let me explain each column. The course code and course name identify the course within the program. The CLO number is a unique identifier for each learning outcome defined for the course, that is your CLO. CLO description clearly states what a student should be able to do after completing the course. So these statements should be measurable and action oriented. Next we have columns for PLO1, PLO2, PLO3 and so on. If a CLO contributes to a particular PLO, we mark it with a 1 or check sheet. If it doesn't contribute, we mark it with 0. This numeric approach allows us to later calculate coverage and attainment quantitatively, which is very useful for accreditation reviews. Finally, the remarks column is used to provide additional explanation or justification. For example, identifying whether a CLO is a core contributor or a supporting outcome. So overall, this matrix ensures that all PLOs are adequately addressed across the curriculum and no outcome is left unsupported. Next template is CLO assessment sheet. This next template is a CLO attainment sheet which is used to evaluate student performance at the course level. So each row in this sheet represents one student's assessment for a specific CLO. The student ID and name uniquely identifies a student. Course column indicates which course is being assessed. CLO number and CLO description specify exactly what learning outcome is being measured. The assessment type shows the method used for assessment, such as quiz, assignment, lab, project, or final exam, and this helps demonstrate the use of direct assessment methods. The maximum marks and marks obtained columns capture raw assessment data. The percentage score is automatically calculated using a formula, so this ensures consistency and reduces manual error. So based on this percentage, the achievement level column categorizes performance as maybe excellent or satisfactory, marginal or unsatisfactory. So these levels are usually defined by the department and approved in academic councils. Next template is PLO attainment summary sheet. Once the CLOs are assessed, we move to PLO attainment summary sheet. This sheet aggregates CLO level data to evaluate program level objectives, which is a core requirement for OBE. The PLO number and PLO description defines the specific program outcome being measured. The related CLOs column lists all the CLOs that contribute to this PLO based on the CLO PLO mapping matrix. The average percentage achievement is calculated from CLO assessment data using Excel formulas. You can use Excel formulas. So this represents how well students on average are achieving this PLO. Then the target percentage is the benchmark set by the institution or maybe accreditation body, commonly 70% or 75%. The attainment status is automatically determined using by comparing the achievement percentage with the target. If the target is met, PLO is considered achieved. Otherwise, it is flagged as not achieved. The actions or remarks column is critical for CQI. If a PLO is not achieved, this column documents the planned improvement actions. So this sheet provides a clear and quantitative evidence of PLO attainment and directly feeds into your continuous quality improvement. Next template is CQI log. So this template is the continuous quality improvement log, which documents how assessment data is used to improve the program. So the semester column indicates when the issue was identified. The course column shows where the issue originated. The data source identifies where the issue came from, CLO assessment results, or maybe student feedback or alumni survey or employer feedback. The findings or issues column summarizes the problem. For example, low attainment of a particular PLO or a student dissatisfaction with maybe the lab infrastructure or lab facilities. The action plan describes the corrective or improvement steps to be taken. These actions must be time-bound, realistic, and measurable. The responsible person ensures the accountability by assigning ownership of the action. Status column tracks progress, that is planned, ongoing, or completed. Finally, the review date specifies when the effectiveness of the action will be evaluated. So this CQI log is one of the most important documents during accreditation visits, as it proves that the assessment results are actively used for improvement. Next template is stakeholder feedback. So the final template is the stakeholder feedback form, which supports indirect assessment in OBE. Stakeholders include your alumni, employers, your industry advisors, and sometimes your internship supervisors. The name and role columns identify the stakeholder providing the feedback. Program column specifies the academic program being evaluated. PLO number links the feedback to a specific program learning outcome, your PLO. The feedback rating, usually on the scale of 1 to 5, provide a quantitative measure of stakeholder satisfaction. The comments or suggestions column captures qualitative insights. For example, skill gaps, strengths, or emerging industry needs. So this indirect feedback complements direct assessment data and provides a more holistic picture of your program effectiveness. So accreditation bodies expect institutions to triangulate data from multiple sources. So this form plays a key role in that process. So that's it. Thanks for watching. I hope this video has helped you to understand OBE, the accreditation process, the assessment methods, and all the relevant concepts that are involved in CQI and OBE. Stay tuned for similar sessions.